We're now going to talk about how we can apply our understanding of logarithms to application questions. So we've done application questions just using exponentials, but now we can actually apply logs to be able to find some of the information that algebraically that before we could only find using technology. So our first question is to find the time taken for a radioactive substance which has a decay function of m of t equals m0 times 4 to the negative 0.05 t grams to decrease by 60% of its original mass, where t is the time in years. Now what you'll probably first notice up there is that we actually have two unknowns. We've got m0 and we've got t. We've got two unknowns, and normally we only want one unknown. So somehow we want to find a way of getting rid of one of those unknowns. We haven't actually been given a piece of information that enables us to do that. It doesn't appear that we have. We haven't been given that when t equals 5, m of t equals 6 or something like that. But we have been given this information that we want to find the time, we are trying to find the time taken for a substance to decrease by 60% of its original mass. Now 60% of an original mass, well, if we're interpreting what that means, decreased by 60% actually means that we're going to be left with 0.4. It implies that m of t is equal to 0.4 m0. Now that's good because that means we can replace m of t by 0.4 m0, and if we do that, we get that 0.4 m0 is equal to m0 times by 4 to the negative 0.005 t grams. What you should be able to see then is that we can just simply cancel out our m0s. Straight off. Cancel, cancel. So what we get when we do that is we get that 0.4 is equal to 4 to the negative 0.005 t. Now then, if we look a little bit closer at that, we want to be able to get rid of the 4 to the negative 0.05 because we want to get t, we want to find t. So how do we do that? Well, we do log base 4. If we do log base 4 of this, of 4 to the negative 0.05 t, and log base 4 of 0.4, we then know that, well, that's going to immediately get rid of log base 4 of 4, that sort of cancels out. So you get that log base 4 of 0.4 equals negative 0.005 t. Then we just have to get rid of the negative 0.005 t, and we do that by dividing by 0.005. So we get log of 4 of 0.4 divided by negative 0.005 is equal to t. Now if you type that into your calculator, what you get is 132.19 years. Okay? And that would be your answer. Now again, you could do that using log base 10, but I chose to do it using log base 4. Alright, question 2. A farmer monitoring an insect plague finds that the area affected by insect is given by that equation, where n is the number of weeks. Use technology to help sketch the graph, help estimate the time taken for the affected area to reach 5,000 hectares. Now remember, when you're drawing a graph, you're going to 1, draw the asymptote, and 2, you're going to draw the intercepts. Also, when you've got application questions, which you remember, these are not hard, okay? These application questions are not difficult, so don't stress about them, just use your calculator. But remember, you've got to think about them in the context. So if we've got an area affected by insects, we can't get a negative area, and we can't get a negative number of weeks. So we know that this graph will be only in this quadrant here. Only going to be in that first quadrant. It cannot go into anything else. Okay, so really important. Show that you're thinking about what the question is saying. All right, So we're going to label this graph appropriately. We're going to label it as A of n. We've been told actually that's in hectares, and we've got n and we've got in weeks. So these are really simple things to put in a graph. Don't forget to do it. All right. Now, if you look at this on your calculator, you will get that the initial point is 2,000. I know that I've got to find the time taken for the affected area to reach 5,000, so I want to be able to plot at least 5,000. I'm just going to go a box for every 1,000. So I'm going to mark that as 0, 2,000, 4,000, 6,000. Okay? So that would be 2,000 there, and I'm just going to label that as 2,000 because I want to plot a point right there. And then I'm just going to draw it. I don't have a y-intercept, or an x-intercept, sorry, because that's going to be over here in the negatives. So I'm just going to draw it up in an exponential fashion. Like that. And I'm just going to... What I did when I did this is just I put a point in my... I've graphed it on my graphics calculator. And I've just picked another point. So I just picked, I did y-calc, I picked g-sub y-calc, I picked x equals 3, and I found the y value happened to be, and there was no particular reason for picking x equals 3, but I found that the y value equals 4,287.09 or whatever, but I don't really care. I just want another point on here so that I've got a little bit more accuracy going on with my graph. It's going to be 1, that's going to be 2, so I've got 1, it's going to be 2, 3, 4, 5. If I don't plot another point, then it's pretty hard to get an accurate graph and then to be able to read a value off it, basically. So that's going to be 3. 3. And that's going to be 4,287. So that's 2,000. That's going to be 4,000. That's going to be 5,000. So about there. Okay. So it just gives me 2 points that I can sketch a little bit more accurately with. That's a good idea to do that. Otherwise, you're just sort of randomly drawing a line in the air. Right, and that's a really bad dot, but you're not using a stylus, so it should work better for you. All right, and make sure you make it look exponential. Okay, and not crooked. All right, so then we can just do the next bit, how to estimate the time taken. Really important. If you've got 2 bits in a question, circle the bits and don't forget them. So do that bit, cross it out, and then do the next bit. So to reach 5,000 hectares, so 5,000 would be across here. And then go down. And so that's going to be about approximately 3.5 weeks. Okay, it's going to be approximate, that's fine. Now, check your answer to A using logarithms. So we're working out the time taken, we're working out n when A is 5,000. So we can go that 1,000 times 2 to the 0.7 n is equal to 5,000. Now obviously we're going to get rid of the 1,000 by dividing, so we get 0.7 n equals 5,000 over 1,000, which is just equal to 5. Then we want to get rid of that base, so we can go log base 2 of 2 to the 0.7 n equals log base 2 of 5. And so we're going to get 0.7 n equals log base 2 of 5, so n equals log base 2 of 5 over 0.7, which if you put in the calculator, n equals 3.32 weeks. Now it's not exactly the same, but it's close, and you would expect there to be some variation because you're doing an approximation. So you should be fine with that. Okay, hopefully that makes sense. So they're not hard, they're just actually being able to find some values now using your logs.